Hi, my name is Steve Cook. I'm the inventor of DSL Rings technology and the founder of Genesis Technical Systems. I'm currently the president and CTO of the company. Following this is a selection of questions that hopefully you will find informative. I've tried to answer them as best I can. If you have any questions, please feel free to visit our website and send me an email. All the best. Thanks so much. Bye-bye.
That is amazing bandwidth. How do you know it works?
In the last couple of days, in fact, in the last couple of weeks, we have been to two of the largest incumbent telephone company labs in Europe. They know it works, they've tested it out, and we've also demonstrated it at several industry trade shows. Thanks for the question.
If you are joining the houses together, that means it's shared, right?
Mm-hmm.
What keeps my neighbor from looking at my data?
Good question. A couple of different parts to the answer. First one is that the data is encrypted between your house and the DP. So even if it does go past their house, they can't understand it even if they could look at it. Second part is that if your neighbors are on this side, for instance, the traffic goes the shortest path around here. So these neighbors wouldn't get to see it anyway. And the data coming back from the network would go around to here, and it only gets as far as your house. So it does not continue on as it does in a cable network, where everybody can see everything that's on the same cable.
What happens if one of the houses burns down or one of the houses doesn't want internet? How does it affect my bandwidth?
Good question. So, first thing is, this here is a blow up of the DP or pedestal on your street corner. We've put this piece of equipment we call a convergence node in, and that's our bonded interface back to the central office. These are obviously the houses. The 2 pairs per house. One goes from the convergence node to the house, and then it comes back where there's a jumper that connects to the second house, and so on. Now, if this house gets burns down or is no longer in the ring, the wires are cut in any fashion, what happens instantly is that the traffic that this guy was sending in that direction now goes back in this direction. And the same thing with this guy, the traffic he was sending that way now goes back this way. And their bandwidth drops by half to begin with. Then we have a little switch matrix up here that actually switches that guy out, so that this here becomes the connection and not this one, so that this guy now switches past him to the next guy and restores your full bandwidth.
What if a few of the houses on the same street are on the internet at the same time? Will that slow down my internet?
A couple of different considerations there. The first one is that there is a technology that we use. As you can tell, we go around, this is called logically a ring. So we took a protocol that's specifically designed for ring networks from the optics and brought it down and put it on the copper. What that technology is called RPR, Resilient Packet Ring, and it provides something called quality of service. Now what that means is that if your voice traffic is set at priority 1, it's unaffected by anything below it. And let's say your streaming high-def video is priority 2, and your internet is priority 5. So the point is that the internet traffic only gets access to the bandwidth that's available on the ring at the time after those other higher priority and, quite frankly, higher revenue traffic have already gotten onto the ring. So it depends on how much traffic is going around the ring, what quality level or traffic priority level that traffic is being added into, and in which direction around the ring it goes for instance, if this direction is very congested and this one is not. So there are always two paths around the ring.
How long till this technology becomes available?
Right now we're doing our prototypes and lab trials. We anticipate commercialization by the end of 2011.
If this offers amazing bandwidth, then why are some telcos still going ahead with fiber?
Most people in the telecom industry have been thinking that the only way to higher bandwidth for years has been optical fiber. No one has ever actually looked at reusing the existing copper. In fact, the architecture of the copper network is over 100 years old. So all we have done is change the architecture of the copper network, and by so doing we have achieved bandwidths that are in the fiber realm and are between 1 and 5% the cost of deploying optical fiber. So yes, we're new, but once the word gets out, there'll be a lot less fiber going out.
Nothing lasts forever. The copper is not getting any younger. Won't the copper have to be replaced at some point?
In general, the copper has lasted for a long time, and it will last much longer. However, we do have network evolution plan, where depending on where the copper dies, so the biggest part of the copper, the most congested part of the network, is from your street corner back into the network. That portion can be replaced by fiber far cheaper than this portion here from your street corner to your house. So that portion, as I mentioned before, we take the optical rings protocol and we've put it here house to house. We can then extend that optical rings from the central offices and put it to connect to the convergence node here and bypass this copper and just use it potentially to provide power to this node.
This concept seems simple. Why hasn't it been thought of before?
Like many significant inventions, it's simple only when it's explained to you. So we've taken 3 different existing technologies and combined them in a network whose architecture has been untouched for 100 years. So the people in that who operate that network and deal with it on a day-by-day basis just haven't considered changing that architecture.